In this video, I'll present information from Chapter 15 of Human Anatomy and Physiology, 11th edition. This chapter focuses on the special senses. In particular, I'll introduce the special senses and discuss the structures of the eye. Specialist senses include vision, hearing, taste, smell, and equilibrium, or balance. What makes these senses special is that they include special sensory receptors. These are distinct receptor cells that are housed in specialized structures. Those structures include things like the eyes, the ears, the taste buds, and the olfactory epithelium. Now I'll introduce some of the structures of the eye, which is the organ of vision. First, let's look at the accessory structures of the eye. These are structures that support the eye and protect the eye from the environment. This includes structures like the eyebrows and eyelids, as well as the conjunctiva, which is mucous membranes that are over the surface of the eye. Additionally, as I'll go over in more detail, it includes the lacrimal apparatus and the extrinsic eye muscles. So let's look a little more closely at the lacrimal apparatus. This actually includes 4 connected structures. We have the lacrimal gland. This produces and secretes tears, and those tears are secreted into lacrimal ducts, or the tear ducts. This funnels those tears over the surface of the eye to the lacrimal sac, which is on the opposite surface, so it's on the medial side of the eye. And the lacrimal sac is where the tears drain into the nasolacrimal duct, which allows them to flow down into the nasal cavity. Those tears, or lacrimal secretions, have several functions. So first, they cleanse and protect the eye. They do this with inclusions such as mucus, antibodies, as well as enzymes like lysozyme that attack bacteria. Additionally, the tears moisturize and lubricate the eyes, and this is with a dilute saline solution. So that's the 4 connected structures of the lacrimal apparatus and its function as producer and secretor of tears, or lacrimal secretions. Now let's take a look at the extrinsic eye muscles. We have 6 of these muscles that are connected to the sclera of the eye. These include the rectus muscles. There are 4 of these rectus muscles. Superior rectus on the superior side of the eye, inferior on the inferior side, lateral on the lateral side of the eye, and medial on the medial side of the eye. Additionally, there are 2 oblique muscles, which rather than connecting straight up and down, or left and right, they connect at an angle to the eye, hence oblique. And there's one on the top of the eye, the superior oblique, and there's one on the bottom of the eye, known as the inferior oblique. And these are used to move the eyes in different directions. So for instance, if you wanted to look up with your eye, you would use the superior rectus and somewhat the superior oblique. If you want to move laterally with your eye, you would use the lateral rectus, and so on. That's spelled out again in this table from your textbook, looking at the lateral rectus moving the eye laterally, the medial, medially, etc. Now, looking in the eye itself, what we're going to find is that there are actually 2 fluid-filled cavities, and those cavities are divided by the lens. First, we have the anterior segment. This cavity exists between the lens and the cornea, and it is filled with a fluid called the aqueous humor. And then we have this much larger posterior segment, and this is a cavity that is between the optic disc, or retina, and the lens. This posterior segment is also filled with a fluid, and this fluid is called a vitreous humor. That lens right there in the middle that separates those 2 cavities, it not only is an adjustable focusing apparatus, but it is the separation point between the anterior and posterior segments. Now we can look at the layers of the eye, and there are 3 of them. The first and most superficial layer is the fibrous layer, and this includes 2 major structures, the sclera, which is the white of your eye, and the cornea, which is a focusing element that also protects the lens. So first, the sclera. This is a very tough membrane, or a very tough layer around the eye. It has to be tough because it's going to maintain this round shape of the eye, but it's also an anchor point for those accessory eye muscles that we looked at earlier. The cornea needs to be crystal clear and shaped properly because it is doing most of the focusing of light in your eye, and it also needs to protect the lens underneath. So those are the 2 major parts of the fibrous layer of the eye. The most intermediate layer is the vascular layer of the eye. This is layer number 2, and it includes 3 major structures. First, the choroid. This is a layer that contains many blood vessels, but additionally, it has a dark brown color that serves to absorb light. And this is important because we want to prevent light from bouncing around in the eye. We want it to hit a point on the retina and stay there. That's going to make sure that our light is focused and we can see objects clearly. Additionally, we have the ciliary body. This includes several substructures, but it has 2 major functions. The ciliary body controls the shape of the lens. So depending on how close an object is, the lens will change shape because the ciliary body can move it. Additionally, the ciliary body is responsible for secreting the vitreous humor that fills this posterior segment. And then finally, the third structure of the vascular layer is the iris. The iris would be the colored part of the eye, and additionally, it has a central hole called the pupil. We can look a little bit more at the iris from a different angle. We'll look at the front. We're used to seeing it like this with some color around the pupil. However, I'm going to remind you that the autonomic nervous system actually can regulate pupil diameter, and it does that by affecting smooth muscles that make up most of the iris. So when the parasympathetic system is active, that's going to cause these smooth muscles to contract and the pupil constricts. When the sympathetic system is active, that causes those smooth muscles to relax and the pupil dilates. So now we get to the third and most deep layer of the eye, and this is known as the inner layer, but more commonly it's just called the retina. The retina actually includes 2 sublayers. First, we have a pigmented layer, and like the choroid underneath it, or over it really, it is meant to absorb light and prevent the scatter of that light. So really make sure that the light is focused so you can get a clear image. Additionally, it physically supports the photoreceptors that are responsible for detecting the light. And then we have the neural layer, and that's shown in here as well. It has a lot of cells in it, and it's going to play the direct role in vision. So those are the 2 sublayers of the retina, the pigmented layer and the neural layer. So if we look more closely at the neural layer, and you can actually see the pigmented layer over here, very thin over here on the right, but the rest of this would be the neural layer. And this is the layer in which photoreceptors exist. And these photoreceptors serve to detect photons, which are particles of light. So there are going to be the sensory receptor cells of vision. If you look over the surface of the retina, you'll find one spot at which photoreceptors do not exist. And that's because in that spot, there's already a structure in place. And that structure is called the optic disc. This is where the axons coming from the neural layer of the retina bundle up and form the optic nerve. And the optic nerve exits the eye at this point, the optic disc. Additionally, this is where arteries and veins of the retina enter and exit the eye. However, One thing I will mention before moving on is that this optic disc can be detected by closing one eye and then moving a small object to and from your face. And at a certain distance, you'll see that object disappear, and that would be your blind spot. And it's representing the optic disc. I'll leave you with this question before moving on to the next video.